Imagine three suns locked in a cosmic dance, spinning around each other like glowing lanterns in a black ocean. What happens if one goes rogue? Stay to the end, because this triple star has a dramatic secret. In this video, you'll see how a triple star system is born, how its three stars move together, what strange planets could exist there, and the wild fate that may tear the system apart at the end. Picture a night sky where the sun rises 3 times, no dark blue dawn but shifting colors as each star takes its turn lighting alien skies. That's everyday life in a triple star system. But first, what exactly is a triple star system? It's simply 3 stars held together by gravity, orbiting a common center, like 3 dancers circling an invisible point in the middle. Most triple systems form in giant clouds of gas. As the cloud collapses, it can split into several clumps. Instead of one big star, you get 2 or 3, each igniting and locking into a shared orbit. Gravity then shapes the dance. Often 2 stars orbit very close, like partners, while the third circles farther out, almost like a distant spectator pulled along by their combined mass. Let's focus on one example, a stable triple system with a close pair and one far companion. The close pair spins quickly, while the outer star drifts slowly, taking centuries to complete one grand loop. Now imagine standing on a planet orbiting all 3 stars at once. From that world, the triple system would look like 3 bright points tracing slow patterns, sometimes forming triangles across the sky. On such a planet, day becomes complex. One star might set while another rises, giving layered twilights of different colors, and only when all 3 dip below the horizon would true night finally arrive. Could planets even survive in a triple system? Yes, if their orbits are wide and stable enough. They tend to circle far outside the 3 stars, treating them almost like a single fuzzy center of gravity. Closer in, things get chaotic. If a planet tried to orbit just one star in a close triple, the tug-of-war from the others could stretch its path, twist it into loops, or even fling it completely out of the system. Astronomers actually find triple systems by watching how starlight changes. When one star passes in front of another, or they tug each other slightly, the light flickers and shifts in rhythm with their orbit. Sometimes they also use the wobble effect. As the 3 stars orbit, their combined pull makes the whole group sway back and forth slightly, and this tiny motion can be detected with precise instruments. Triple stars can be very different from one another. One massive and bright, one medium, one small and dim. Their different temperatures paint the sky with mixed hues, blue, white, golden, and faint orange glows. The orbits might not be perfect circles either. They can stretch into long ovals, bringing stars closer at some times and flinging them farther apart at others, changing the light a planet would receive. Over millions of years, these orbits can evolve. Gravity trades energy between the stars, slowly twisting their paths and tilting their orbital planes, while still keeping the overall system bound for now. But sometimes, things go unstable. A close encounter can sling one star outward like a cosmic slingshot. If it gains enough speed, it escapes completely, turning a triple system into a double and a lonely runaway. From a distance, that ejected star would race through the galaxy alone, still shining but no longer part of its original family. Its path bends subtly in the galaxy's gravity, like a spark drifting in a grand whirl. Back in the remaining pair, the orbits tighten. Losing one member changes the balance, drawing the surviving 2 closer together into a faster, more compact dance around their shared center of mass. In other triple systems, the drama comes from stellar life cycles. A massive star can swell into a red giant, its outer layers sweeping over a companion, stealing or dumping material and reshaping orbits. Imagine the sky view then. One tiny sharp star and one huge bloated red sun filling a large piece of the heavens, while the third star glides slowly behind them, turning the scene into a moving 3-part tapestry. For a planet, this could mean wild climate shifts. As stars brighten, dim, or change position, the total light and heat can rise and fall, giving long eras of warmth, followed by ages of cold twilight. Yet triple systems might also offer surprisingly stable zones. Far enough away, a planet can experience averaged-out light from all three stars, giving a more constant energy input than you'd first expect. Some exoplanets discovered near multiple stars could even see permanent glows in the sky. Even at night, at least one sun might hang low, painting the landscape in gentle, never-ending twilight. Scientists study triple systems to test gravity itself. Precise measurements of how three bodies move together reveal tiny deviations, helping confirm or challenge our theories about how the universe works. They also matter for galactic evolution. When triple systems break apart, they help stars through space, seeding different regions of the galaxy and stirring its large-scale structure over billions of years. So next time you look up at the night sky, remember, that single point, it could hide three stars bound together, orbiting silently in deep space, shaping unseen worlds and rewriting their own fate. If you want to explore more strange systems, like planets in eternal twilight or stars on the edge of black holes, hit subscribe and stay curious, because space always has another twist waiting for us.